All right, let's take a look at DMR. Tomorrow's your quiz. Use this graph to answer the question below. How many more hours of light usage does the swimming pool use than the tennis courts? So we're going to look at the swimming pool. I see it has light bulbs according to the key or the scale. One light bulb equals 10, so I'm counting by tens. So that's 10, 20, 30, 40, 50, and half of a 10. Oh, that equals 5. So this is 55 hours of light usage. For the tennis courts, there is 10, 20, 30, 40, 50. 50 hours of light usage. So that means that the swimming pool uses 5 hours more light usage. Questions on that? Terrence, you like to talk today. I don't even believe you have a question. I think you just want to hear yourself talk. What's up? Can't hear you. Still can't hear you. There you go.
Can you hear me now?
Yes.
So is there a way for you to make us so we can draw?
Yes, it's called this wonderful invention named a notebook and a pencil. And then you take the pencil, and when you rub it on the notebook, the lead creates a traced line, and then you can see like where your hand made the pencil rub on the paper. Have you ever seen these? You haven't? They're really cool. They're old school, but they're awesome. All right. Next up, Geo is taking a train from Carlton to Elgin. The train leaves Carlton at 9:25 a.m. and reaches Elgin at 9:55 a.m. How long does the train ride last? Use the number line to find out. Well, this number line did a very nice thing for us, and it gave us a little bit of a clue here. 9:25 to 10:25. Notice that right here, all this did was change the hour. 9 went to 10, 25 stayed the same. So that is 1 hour. So we know it's going to be at least 1 hour. Okay, so we're going to get rid of 10:55 because that's not a how long, that is a time itself. Okay, William, you are full of jokes. There isn't enough information. That's not true. We have plenty of information. So let's see what else we can add here. Okay, now we're going to go from 10:25 to 10:55. I notice those both end in 5, so I can count by 5s. 25, 30, 35, 40, 45, 50, 55. That's 6 5s, which is equal to 30. So this is 1 hour and 30 minutes. So our correct answer is 1 hour and 30 minutes. Okay. Any questions? Yes, Leah.
So you can also do, if you look at the numbers, you can see there's a 9 and a 10. There's not an 11. So you can cross off 2 hours and
Beautiful.
55.
Way to think ahead. If it was going to be 2 hours, it would have to be in at least 11 because 9, 10, 11. Great connection there, Leah. Yes, Willem.
It can also be called an hour and a half.
It can also be called an hour and a half because 30 minutes is half of an hour. Look at your brains go. All right, next up, how many faces does this solid figure have? There were 2 correct answers to this yesterday, and let's talk about why. Your correct answer could have been 1. Your correct answer could have been 2. And here's why. Because it depends on who you talk to. Even the state of Indiana, the Indiana Department of Education gives 2 different answers. On one website, it says there's 1. On the other website, it says there's 2, which is goofy. Here's why. We have 1 face down here, and it's a circle. This is a flat circle. Okay, so that one we got. We're good to go on that one. The other one is this funky shape here, which is actually similar to a rectangle being rolled up, right? We've talked about this. So I take this napkin here, it's flat. And then when I roll it, it's a cone and it's got that circle spot. Okay. So this is what we call a curved surface. Some people say curved surfaces are faces because if you unroll it, it's flat. Some people say they're not faces because it's not flat. So either one would have worked here. Okay. You can say it has one face because there's only one flat part. That's the circle. You can say it has two because it curves and it is flat if you unroll it. Okay. So either one, we're good with it. Questions on that? Yes, William, it does look like ice cream. Here's a nice strawberry ice cream cone for you. That sounds so good right now. Get some sprinkles up in there. Woo. All right, there we go. Next up, which tool would be used to measure the temperature of a glass of water? Okay, temperature. We don't use paper to measure temperature, but remember, Terrence, we do use paper to draw. We don't use a ruler to measure temperature. That's the length. We don't use a scale to measure temperature. That's the weight. So we use a thermometer. So you should have selected the answer, thermometer. Questions? All right. 700 minus 699. I hope y'all saw that connection, because you guys know after 99 is a new 100 and after 6 comes 7. So hopefully you figured out that that equals 1. But if you didn't, let's talk about why. We got some double borrowing going on here. Got a 0, can't subtract 9. It goes to the 0, nothing there, goes to the hundreds. So that's going to become a 600, that's going to become a 10. Remember when I had the $10 bills and I showed y'all how that's still 100, there's just more papers? That's what's going on right now, okay? Then we're going to borrow a 10 and turn it into 10 ones. So right now, we've still got 700 at the top. $600 bills plus 9 $10 bills plus 10 $1 bills is still $700. It just looks different, okay? Now the subtraction comes. 10 minus 9 equals 1. Boop. 9 minus 9 equals 0. 6 minus 6 equals 0. So our correct answer is 1. Questions? Questions, questions, questions. Okay. Let's take a look at the how long is the object in inches. Okay, here we go. Let's count what we do know, what we can see easily. Starts at 0, yay. There's 1 whole inch. There's 2 whole inches. Okay, so this pencil is at least 2 inches. So I'm going to get rid of 1/4. And I'm also going to get rid of 2 because I can see that there's some extra. This extra is 1 hop. This ruler is divided into fourths. So 1 hop is equal to 1/4. I also have that in my notebook. The first hop is a 1/4. Okay, questions on that? Yes, Leah.
If you looked at the tip, you would have known if it's not half. So I would cross off 2 and 1 inches because it's not fully half.
Awesome. We know that the half is in the middle, and you can also see that it's not there. Yep. Okay. There we go, friends. That's your DMR. You got a last day of practice today. You got your test tomorrow. I'm looking forward to A+. All right, let's hop to it, friends. We're going to continue on with our look at weight. Yesterday, we worked on estimating weight, okay? Trying to figure out what we can get it the closest to. Today, we're going to look at actual weights, okay? Reading scales and looking at the exact measurement, okay? If you would, please hop to your activities. Activities is... The activity is called, I apologize, Measuring the weight of objects, Indiana lesson 5. Go ahead and click on that add response. And you're going to see our goal. Here is our goal for today.
Yesterday, you spent time choosing appropriate tools to estimate weight and estimating weight in pounds. Today, we're going to be looking further into the appropriate tools to estimate and measure weight, and really focusing on measuring weight in pounds. So today, we're really focusing on the appropriate tools to measure weight and measuring weight in pounds. One of the tools that we use for this is called a pan scale. And a pan scale right here is used when you just want to measure one thing to determine its weight. The other type of scale is called a balance scale, and that's down here. And that's when you might want to just compare weights of different objects. So today we will be looking at both of these types of tools.
Okay, let's hop to slide 2, please. I have a brain pop that we're going to watch, and then we're going to fill in this chart. We're going to use these down here. Okay. So take a look, watch the video, then fill in the chart. We're going to see how many ounces are in 1 pound, how many pounds are in 1 ton. And then we're going to sort these from lightest to heaviest. Okay, so pay attention to what is an ounce, what is a pound, what is a ton, and how many are in each. Here we go.
Let's see. This weighs about... Hey! I was trying to weigh that apple. What is weight? Weight describes how heavy something is. Some things are heavy and weigh a lot, while other things are lighter and weigh less. You can use a balance to compare the weights of different objects. The side with the stapler moves down. That means the stapler is heavier than the eraser. Right, Moby. The stapler is bigger than the eraser. But just because something is bigger, it doesn't mean it has to be heavier. Which ball is heavier? The beach ball is bigger than the baseball, but it's lighter. What are ounces? An ounce is a small unit of measurement. A slice of bread weighs about 1 ounce. A scale is a tool that measures weight. Let's see. That pear weighs 10 ounces. We use the abbreviation OZ to stand for ounces.
Did you see that, Terrence? Look, I'm going to back it up a little bit. Hold on. She's drawing. Watch here. See that?
We use the abbreviation OZ to
Love you.
stand for ounces. You can use ounces to measure light things, like a banana, a potato, or a pepper. What are pounds? You can use pounds to measure heavier objects. A loaf of bread weighs about a pound. The broccoli weighs 1 pound. We use the abbreviation LB to stand for pound. 1 pound is equal to 16 ounces. That means your broccoli weighs 16 ounces. Let's see. This pineapple weighs 5 pounds. We use the abbreviation LBS to stand for pounds when it's plural. You can use pounds to measure heavier things, like cauliflower, eggplant, or carrots. That pumpkin weighs 8 pounds and 1, 2, 3, 4 ounces. You can count the tick marks to count the ounces.
Tick marks, clock face, connection.
The world's largest pumpkin is over 1,000 pounds. What are tons? To measure really heavy things, you can use tons. A small car weighs about 1 ton. 1 ton is equal to 2,000 pounds. So that means a small car weighs about 2,000 pounds. The largest living animal on Earth is a blue whale. It can weigh about 150 tons, which is equal to 300,000 pounds. When you weigh things, decide which unit of measurement makes sense. It doesn't make sense to weigh crayons in pounds or tons. You should weigh it in ounces because it's light. If you want to weigh yourself, you could use pounds and ounces.
Same, Moby, same. All right, let's take a look. That video just told us that there are 16 ounces in 1 pound. Go ahead and write that down. This isn't really anything you can discover or figure out. It's just something that is. It is a memorized fact, okay? 16 ounces are in 1 pound. There are 2,000 pounds in 1 ton. So if you really want to have your mind blown, let's see how many ounces are in a ton. Okay, so there are 16 ounces in 1 pound. There are 2,000 pounds in 1 ton. So that would mean if we wanted to find out how many ounces, we would multiply 16 by the 2,000. There are 32,000 ounces in 1 ton. That's a lot of ounces. So sort the weights from the heaviest to the lightest. Well, we start with our smallest object, and that's an ounce. An ounce is the tiniest unit of measure that we use in a standard world, okay? Now, I'm sure scientists who are weighing like cells probably have different units of measure, but for what we'll accomplish in our daily lives with water bottles or shampoo or a suitcase or a scale for your body, we're going to look at ounces and pounds mostly, okay? Then we have a pound. A pound is made of 16 ounces. And finally, we have a ton. A ton is going to be 2,000 pounds. Okay, so these are from lightest to heaviest. An ounce weighs the least. A pound is that middle. And then a ton weighs the most. Questions on this vocabulary? Okay, let's hop to slide 3. We're going to watch a video, and then you are going to discuss with your partner, what can you determine about the tape and lemon from this balance scale? Okay, what simple machine do you see being used in this? We're going to measure, but not in the way you think. Watch this. A ruler. what simple machine did we see here? What simple machine was being used? Angie?
I saw an inclined plane, like a seesaw.
A seesaw, which is a lever. Yes, a lever does use an inclined plane. So a lever. Okay, we saw a lever. All right, with your partner, I'm going to pop you in a breakout room for a very quick discussion. What can you determine about the tape and the lemon from this balance scale? Here's the tape. Here's the lemon. What can you figure out? Okay, Levin, go for it.
The reason why they said the tape is heavier is because the tape holder is heavier than the lemon.
How do you know?
Because from my instincts, when I've held one before.
Okay.
I've held-
So a connection. All right. Looking at the scale, how do we know, guys? Looking at the scale, how do we know? Yes, William.
Because on the scale you can see that the tape is weighing down the lemon.
Yes, this is the lower end. It's weighing down on that side. Excellent. So when something is weighing down, that is a phrase that we use for when something is heavy, okay? Because the scale is tipping downward. Yes, Leah.
So I know that the tape is heavier because the lemon is really small and it's higher up.
It is higher up on the scale, yes. So remember, the size necessarily isn't going to tell us about the weight, just like that beach ball, baseball example, but the position of the scale will. Yes, Terrence. Can't hear you, baby.
The reason I know that the lemon is not heavier than the tape is because the heavier opponent is always on the side because it lifts up the lemon.
The heavier opponent is always going to be on the downward side. Yes, on the lower end, because it's going to lift up the other side. Yes, Tim.
Skip you back to slide 2 because I missed that slide.
There you go. Lots of different connections, lots of different ways to say the same thing. On our scale, our balance scale, whichever end goes down has the heavier object. Okay, its weight will drag the scale down. All right. Okay, let's hop to slide 4. This is an example of what you are going to do today. Today, you are going to be reading scales. I want you to pay very, very, very close attention to these scales before you read them. Read the pan scale and record the weight of the objects below. Then complete the sentence to compare the object. Here's why I want you to be careful. Take a look at the scale that has the potatoes. Look at the highest number on this scale. It's 18 pounds. Take a look at the jelly beans. The highest number on this scale is 9 pounds. So these are not like clock faces where they are all the same. Some scales are used to measure, that's not a word, to measure heavier objects so they will have a larger number on them. Some scales are only used to measure lighter objects so their total will be less. Okay, so I don't want you to get tripped up today by thinking just because the needle's over here, it's a bigger one. It's not a heavier one, okay? So let's take a look. This is how we'll read the scale. The potatoes started at 0 and went all the way around and stopped at 10. This needle is pointing to 10. So the potato weighs 10 pounds. Please write that on the line. The jelly beans, starting at 0, go around and have stopped here. This needle is pointing to a 4. So the jelly beans weigh 4 pounds. The potato weighs blank than the jelly beans. We're going to drag a word. The potato weighs more than the jelly beans because, typey, typey, typey. Style, where's the style? The potato weighs more than the jelly beans because 10 pounds is greater than 4 pounds. Using our math vocabulary with words like greater than, less than, equal to. Any questions on what you're going to do today? Okay. Your assignment that is going to be assessed today is the rest of these slides. You're going to look at the scales and measure them. Let's do this one together. Your others aren't like this. This must have snuck in there as independent. It was supposed to stay with your teacher. This is an example. Okay, let's look at this one. Read the balance scale to determine the weight. Okay, we've got sugar. Over here, these say 1 pound. Let's count how many there are. 1, 2, 3, 4. So this is a 4-pound bag of sugar. So what they've done is they've put, just like on that lever that we saw, they've put the sugar on one end, and then they added a pound, until it was even and it leveled out. When they balance, right, just like a balance beam, when they're the same, they equal the same amount. So it took 4 pounds, 1, 2, 3, 4, to get it balanced and straight. Okay. Take a look at the cabbage. Cabbage has 1, 2, 3, 4. It also has 4 pounds. So these would be equal to. That's how you would read a balance scale. Okay. All right, now the rest of these slides are just like what we did on slide 4. You are going to look at the objects. You are going to read the scale and record them. You are also going to be taking a look at the sentence and finishing it. 1 slide is worth 3 points. There's a point for reading the first scale, a point for reading the third scale, and a point for the sentence. Okay, we tracking? All right. What questions can I answer right now? All right, friends. I want to go over a few things with you before you hop off, so please stay here.